Alright, okay, so welcome back, dears. Hello, ayan. So welcome to the part 2 and hopefully the last video na for our applied bacteriology, focusing on water and a little about milk bacteriology, okay? And for this part, we're going now to start with the second method in testing for water bacteriology, and that is the heterotrophic plate count, or HPC. Now, this is usually used for testing bottled water. Okay, katong multiple tube fermentation test, usually other sources of water to, like katong surface water, no, groundwater, or other sources of water. Usually na ginainom na to. But for this heterotrophic plate count, we usually used it for bottled water. Okay, so if we want to test bottled water, we undergo or we subject the sample into heterotrophic plate count. Okay, now what is heterotrophic plate count? Now, heterotrophic plate count, also known as your standard plate count, it's a procedure pa rin to enumerate or to determine the concentration of the bacteria na naa sa imuhang water. But this time, what we're detecting are heterotrophic bacteria. Okay, so not the fecal coliforms anymore. So other types of bacteria that are present in water that grows at 35 degrees Celsius with 48 to 72 hours again in bottled water. And when you say again heterotrophs, when you say heterotrophs, diba, recall in your bacte, basic na mga terminologies, diba, heterotrophs are bacteria that are organisms, not only bacteria, diba, that utilize carbon ba to? Tama ba? Heterotroph from other sources. If my memory serves me right. Okay. So yeah. So again, heterotrophs is a broad term. Not only bacteria, but other microorganisms also. That may include bacteria, yeasts, and molds. Ay, nara din ang definition. They require organic carbon for growth. Okay. So those are now what we are detecting. Now, your HPC, usually, we test this not to detect the pathogens, okay? Or it's not to determine if ang water ba is potable. Not really. We're not detecting mga pathogens or indicator organisms parehas sa MTFT. What we are looking for is if ang pagbottled ba sa water, is the procedure done kanang aseptically or tsakto ba ang pagbottled sa water. Okay? So it's not more on detecting kung unsay mga pathogens na nasa tubig. Okay? It's more on detecting if the factory or the one that is bottling the water, are they following correct na mga procedures? Are they bottling this water aseptically or kanang very meticulously or with with no contamination or minimal contamination in ANA. So it's more on detecting if the bottled water ba is safe in terms of production by the factory, ganun. Okay, all right. So that's a heterotrophic plate count. Okay, now again, it involves a variety of test conditions that lead to a wide range of results. Incubation temperatures, 20 to 40 degrees Celsius. Incubation time may be a few hours to weeks. And nutrient conditions may be low to high. Now, the water should be tested within 12 hours, okay? And it should be kept at temperatures less than, ba to? At temperatures no higher or not higher than 10 degrees Celsius. Ayan. Not higher than 10 degrees Celsius, and the water sample should be tested or analyzed within 12 hours if mag-HPC ka. Okay? Alright. Ayan. And again, it does not specify the organisms that are detected. Again, we are just looking for if the bottled water is produced, okay? Or did the bottled water undergo correct or mga kanang procedures that are safe para sa customers or sa consumers, okay? All right, ayan. Okay. All right. But again, your heterotrophs usually they do not cause diseases. Yeah, have no health risk, okay? But it indicates how effective, ayan. How effective are the treatments, okay? How effective are the treatments in controlling microorganisms? So yeah, as mentioned, it's much more focusing on production, okay? On the procedures and methods of production by the factory ba? Are they following mga correct mga standard procedures in terms of safety from microbiological safety, nana, or para dili ma-contaminate ang water, inana. Alright? So that's heterotrophic plate count or yahang purpose. Now, traditional methods, we have 3 types. You have the pour plate method, which uses 1 ml aliquots, so mas medyo taas na volume. Spread plate method, which atong tang i-perform sa ato ang lab, no, naamoy sa atong lab for water bacteria, magdala mo bottled water, magdala pud mo og katong water from other source, like kanang, kanang water sa OH, kanang sa water fountain, mga inana. Alright, and this is what we will perform unta. Alright, and another method is the membrane filtration method. Okay, alright. Now, we now focus on the spread plate method since mo na itong buhaton. So what we do is your bottled water, no? We get, we dilute it in a tenfold manner pa rin. Alright, so from your first dilution, okay, or your water, no, wala na siya dilution. So we assume na it's 1:1. So 1 ang iyahang initial dilution. Alright, and ang dilution factor niya is of course 1. Now we prepare a tube that's 9 ml of sterile distilled water, okay? Sterile water pa rin, okay? And then we get 1 ml from the bottled water na to, and then we mix. So the initial dilution ana is 1/10 because your sample volume over total volume, that's dilution. So your sample volume is 1 ml, and total volume is 1 ml, which is from your bottled water, plus 9 ml na sterile water. So that's equivalent to 1/10. So muna siya to ang dilution, initial dilution. And the final dilution is 1:10. Okay, so ang final dilution niya is still 1:10 because ang final dilution, mga good guys, is the total dilution from kung asa siya gikan. So gikan man siya og 1:1, di ba? Kanang sa bottled water. So ato na nang i-multiply iyahang initial dilution na 1:10. So that's equivalent to 1:10 na final dilution. Okay? All right? So that's for the first tube. Now, we further dilute it, okay? Of course, dilution factor is reciprocal, 10. Okay? Further dilute, kuha kag 1 ml from here to the second. So, ang initial dilution nimo is still 1:10. Kaya ni kuha makag 1 ml diri, niya 9 ml diri, di ba? So, 1:10. But ang difference na is the final dilution, 1:100. Why? Because ang imuhang gikuhaan na tube, kani, diluted naman siya daan, na siya initial dilution na 1:10. Alright? Now, pagbutang nimo ani na next tube, second tube, that's another dilution na 1:10. So that's why ang iyang final dilution for the third tube or kaning second tube is 1:100. So you multiply that two. All right? That's how you calculate for final dilution. Imong i-multiply ang dilution sa imuhang tube to the dilution of the previous tube kung asa siya gikan. Okay? All right. But if wala siya dilution ang kung asa siya gikan, then of course medyo same lang iyahang dilution. Okay? Alright, so muna siya final dilution. So therefore, atong dilution factor is 1:100. Still the same, follow until the third tube. So multiply Japon ka 1:10 times 1:100, 1:1000. So that's 1,000 dilution factor. Fourth tube, still the same, 1:10 times 1,000, 1:10,000, so 10,000. And finally, we dilute last one, 1:10 times 1:10,000, so 1:100,000, and your dilution factor is 100,000. So this is the spread plate method. So as you can see, mas nagkagagmay ang dilution, mas nagkagagmay ang para as in makakita ta na up to what lowest dilution ba ang naadya po ikagaw. Alright? Because at this small amount, naagya po jud siya ikagaw. Inana ba? So in a way, it speaks volumes about how the bottled water was processed. Because makayon ka na, ani gapo na kagamay na dilution na adya po mutubo. So meaning, di gyud maayo ilahang pag-process in a way, di ba? So I hope na gets na mo sa iyahang gist. Okay, alright. And you discard 1 ml para mo equivalent ra siya. Okay, alright. Okay, ayan. So for our dilution, each of that, ato na siyang i-spread plate technique, kuatag 100 UL, i-incubate or ato siyang i-plate in using nutrient agar lang. Because again, we're looking for heterotrophs. Okay, so heterotrophs could be yeasts, could be bacteria or mold. So ato siya ibutang in a non-selective na medium para mutubo silang tanan. Okay, so Na. Alright? Incubate at normal temperature and obtain the CFU per ml. So mag-count ta. Pila ka colonies ani? So example, 100 UL man. So 100 UL. Example, nakakita kag 50 colonies. So 50, that's equivalent to 50 colonies over 100 UL. Alright? So we just convert the UL to ml. Di ba? Pareha sa urine culture. So 1,000 UL over 1 ml. Di ba? So that's equivalent to 500. Oh, 500 CFU per ml. Ganun. Okay? So, ganun. Okay? Alright. Ayan. So, tama ba? 50? Oh, tama. 500 CFU per ml. So example ra na siya. Okay, so inana ang pag-determine sa CFU per ml. Same ra siya sa again sa imuhang sa imuhang urine culture. Okay, all right, that's for spread plate method. Okay. Now another method is membrane filtration. So when you say membrane filtration, we use a membrane filter. Okay? It can be used to test mga large numbers na of sample and rapidly pud ang pag-produce o result. Dili siya para sa MTFT na daghan kay incubation. Okay? And there, it gives a direct count of bacteria present in the given sample of water. Okay? All right. So it's used for treated and partially treated water. So unsuitable siya with mga natural waters kana mga springs or mga runoffs na daghang mga suspended materials like mga sludges and sediments that may block the filter. Maguba imong machine. Mugamit mo tag machine anim. Okay? And for these samples, natong gamiton, smaller volumes are tested and mag-dilute pa rin tayo. Okay. Alright. So ang typical sample volume natin is about 100 ml. Ayan. So this is the membrane filter. Okay? Muna siya ang ginagamit nato. Okay. Alright. Now for the procedure, so ang imuhang example move, na kay water, no? Ato siyang i-filter. Okay? Para mawala itong mga gagmay na mga sediments. Okay? And it is filtered under vacuum, okay? All right. Using a cellulose acetate na membrane, okay? And ang purpose ana is gi-vacuum ang water para mulapos ang water sa filter, okay? And ang mabilin sa surface sa filter kay kato ng mga bacteria, okay? And this filter, katong cellulose acetate na filter, na naanay mga bacteria or kagaw, muto siya ibutang sa ato ang culture media plate, okay? And incubate, then after a while, nanay mo tubo. Alright? Ayan. And each bacterium or colony na motubo is equivalent to, So each bacterium di ay or bacteria na naa will give rise to a single colony, which is equivalent na to CFU per ml. Alright? Okay, ayan. So this is the machine. So muna siya ang water, no? So nana siya i-filter, dayon so yupon ang water, okay? Sa imuhang vacuum or something. Para mabili na lang jud sa imuhang kaning membrane filter, mura siya host siya, sorry naman. Kaning mura siya filter again. Cellulose acetate is ang mga bacteria sa surface. And then ang membrane filter imo siya ibutang og culture media plate and then incubate para mutubo sila. And kung sa toy makita na mga tubo, then muna na siya ang bacteria na present sa imuhang sample. Okay. So sample funnel dira ibutang imong water, okay? So filter holder and suction katong mga water na mabilin. Okay? Alright. Ayan. And cellulose acetate filter and the vacuum pump. Kani siya handheld daw. So, I think gunitan siya. I'm not sure. Familiar with the procedure. Okay? But, so, vacuumon ang water. Alright? Okay. So, para pag-filter, ma-vacuum tong other sediments or other unwanted materials. Para mabili na lang yun diri sa imuhang filter. Membrane filter is the bacteria. Okay? Alright. Ayan. So, collect the sample. Okay? Make necessary dilutions. Place an absorbent pad on a sterile Petri dish. Okay? Dispense the appropriate medium evenly, saturating the absorbent pad. So, dala mo ibutang imuhang katong membrane filter. Ayan. Membrane filter, flame the forces, remove the membrane from the sterile package, and place it into the funnel, katong sa atong machine ganina. Alright? Next, flame the pouring lip of the sample container, meaning kung asa gikan tong tubig na imong i-test. Alright? And pour the sample into the funnel. Okay? So turn on the vacuum and allow the sample to draw completely through the filter. Rinse the funnel with sterile buffered water. Turn on the vacuum and allow the liquid to draw completely through the filter. So pag on mo sa vacuum, of course, so yupon tong water padulong dito sa catchment. So para at least, again, muagi siya sa, imo siya pag-iunta ng water sa filter para again, ang point is mabiling itong mga kagaw na nasa water on the surface of the filter. Okay? On the cellulose acetate filter. Ayan. And then, kato membrane filter, as mentioned, imo siyang ibutang at imuhang sterile na Petri dish, di ba na absorbent pad, and incubate at the proper temperature. And, ayan. So, kani mga color green, muna na ang tubo. Ayan. So, each clump of that is equivalent to a single CFU per ml, or muna siya imuhang colonies na na-form. And that's equivalent to mga bacteria or organism na nitubo. Alright? So, count the colonies under 10 to 15, and identify the type of contamination. Is it grabe dyan na contamination or dili lang, tolerable, mga ganun. And then report count as CFU per, again, unit volume. So report as CFU per ml. Alright. Okay. And according to DOH, this is for bottled water, no? So kung we're testing for coliforms, so as much as possible, silang tanan 5, okay? 5 ato ang i-test ka tubes or 5 ka samples. Alright? And ang maximum ra dapat is dapat, for coliforms, dapat 1 out of 5 ra ang naa. Okay? Muna siya acceptable. And ang guide level, ang point sa guide level is parang, that is the maximum value attainable in good conditions. So meaning, if, example, compare siya standard ba? So ang guide level is the standard. So under standard conditions, of course, dapat wala gyud, 0. Alright? Pero, of course, dili man tanan under standard conditions. So munang ang acceptable level gyud is 1. Okay? 1 out of 5. Alright? And then we calculate MPN per 100 ml. Okay. Per kaning 1, it shall not be E. coli. Pag test nimo sa imuhang coliforms, it shall not be E. coli. Okay? Because that could indicate that kung na E. coli, ang coliforms na naa sa imong tubig kay fecal origin. So kung ang pasabutan na kung fecal in origin imong coliforms, it could indicate that there are other fecal organisms there in your water that may cause enteric diseases like salmonella na ba, vibrio, whatever. So ganun. All right, okay. Now if we test for fecal streptococcus, still the same, 1 out of 5. 1 ra acceptable level pa rin. Pero again, in under standard conditions or mga good conditions, dapat 0 ra gyud. Okay? Alright? But, na ay asterisk, dapat consider defective ang whole lot of water na imong gitest if another set of 5 samples kay na ay usa na ni positive. So example, first 5 na ni positive. So you test another 5 ka set. Nga na po ni positive. So, ang pasabutan is katong tanang lot or tanang group of bottled water or water ba na imong gitest is considered contaminated or dili siya pwedeng gamiton. Alright? For Pseudomonas aeruginosa, dapat 0 gyud out of 5. Dapat walay mo positive. Okay? Alright? Ayan. And for HBC, heterotrophic plate count, 1 out of 5. Ang guide level dapat is 10 to the 4th ra ang imuhang CFU per ml. But ang pwede pang acceptable is up to 10 to the 6th. Okay? And for purified or distilled water, 10 to the 3rd dapat ang kanadjong murag standard or gold standard na level ra sa imuhang coliforms or kagaw na naa or coliforms or heterotrophic sa mani basta ang kagaw na naa sa imuhang water 10 to the 3rd lang, pero ang acceptable pwede pa siyang up to 10 to the 5th. Okay, so medyo naglibog po kung saan yung pag-analyze, no? Pag-interpret sa result. But I believe inato siya. So I do hope medyo na-gets na to. Okay? Alright, ayan. Okay. And that's it for water bacteriology. Now we go now to milk. Okay, now for milk, it's just gamay lang yun kaayo. Like really like gamay lang yun kayo na info. Kaya wala kayo kakita o notes on this. Wala kayo siya gi-mention po sa ato ang mga references. Wala ko ka-check. Pero it's not that explained well. And kani mga notes ani kay usually gikuha nako from my review kay namang joy mo gawas Japon in the board exam. Naginagmay question from milk bacteriology. And usually they get it from mga reviewers sa medtech from way back mga about mga 20 or 30 years ago. So until now ginagamit Japon sa board of examiners. So that's why ako siyang i-include. All right? Now for milk bacte, yes naman. All right, we focus more on the milk-borne diseases, and these diseases may come in 2 forms. They may be diseases from cow or bovine origin, or diseases from humans or human-born. So, kung diseases from cow, bovine origin meaning gikan sa cow ang kagaw, okay, gikan sa cow ang bacteria, it affects the humans. Okay, so kung cow-borne diseases meaning nakuha siya sa cow. So, ang humans ang naisakit. Whereas, kung human origin, meaning gikan sa tao ang sakit, iyang gi-infect ang cows. Okay, na-gets na? So again, kung bovine origin, gikan ang kagaw sa baka or sa cow, iyang gi-infect ang humans. Okay, so ang humans ang naisakit. Or humans ang nagkasakit. Okay. Pero if human origin, gikan sa humans ang kagaw, iyang gi-infect ang baka. So, ang baka na karon ang nagkasakit. Okay? I do hope na-gets na. Alright. And we have this grade A milk. So, unsay qualifications para na grade A milk? Dapat, ang bacterial count is 75,000 per ml when raw. Okay? Kanadjong fresh. Okay? And dapat dili mo lapas og 15,000 pag na-pasteurize na siya. Diba? Usually for milk, the way of sterilization that is pasteurization. Diba? Diba? Recall in your sterilization nato na chika. Alright. Now, I don't know if na pa mga grade B, grade C, wala na ako naka-search. But ang gi-emphasize na mo is kaning grade A milk. Kaya murag muni ang nigawa sa board exam. So what is unsay bacterial count sa grade A milk? Again, kung raw, dapat 75,000 per ml ra siya. And kung ma-pasteurize, dapat 15,000 ra. Yun sa ako ni pag-remember. Ano ra kayo siya? Kanang, na-remember na ko siya, or like, kanang multiples siya of 15. 15 o 75. So, di ba, 15 times 5 is 75. So, in a way, medyo close na sila. Okay, they are multiples of 15. So, 15 and 75. So, dapat 75,000 ml ang bacteria kung raw, like kanang fresh gyud, gikan pagid sa cow, wala pa gi-sterilize. And dapat dili mo exceed og 15,000 ang kagaw or bacterial count if na-pasteurize na siya. Okay? Or if na-sterilize na. Alright, okay. And the last part for milk bacteria, short ra gyud kaayo, are the possible agents of diseases of bovine origin, diseases of human origin. So, diseases of bovine origin, meaning, these are diseases that cause infection to humans. Nagikan sa kabaw. Hala, ang kabaw. Joke. Ang cow. Gikan sa cow. So, ang affected ani kay humans. Okay? Alright? So, first is, of course, bovine TB and bovis. Undulant fever, brucella abortus. Diba? You have anthrax, B. anthracis. Cowpox is virus. Diba? Recall in your cowpox sa inyong viro. Yes naman, so viro. Member ni siya of the Poxviridae family. Diba? Ayan. And in your immunosero, you'll know that si Edward Jenner, ayan, si Edward Jenner, siya ang naka-discover og, in a way, siya ang nag-discover og variolation. So, iyang gikuha ang cowpox na virus or kana mga scabs sa cowpox, iyang gigaman og murag solution or suspension, and iyang gihatag sa mga patients with smallpox. And in a way, kato mga patients naghihatagan niya naka-develop og immunity against smallpox. So wala na nagkasakit og smallpox, so yung gihatagan ana. You'll have that in your immunosero next sem. Okay. All right. So muna na discover ni Edward Jenner. Okay, all right. And foot and mouth disease caused by aphthovirus and Q fever, o di ba in your bacte karon, caused by Coxiella burnetii. Coxiella burnetii is a rickettsial organism. Part of your rickettsia, okay, again, Coxiella burnetii, one of my favorite po na organisms, kaya ganaan ko yung ngalan. It's rickettsia, part of the rickettsia family, okay? And ang specific or special characteristic niya is that it can be transmitted both airborne, okay? Pwede siyang matransmit sa air, or pwedeng through tick, or vector na lang. Nalimutan ko siyang vector, pero vector, ayan. Okay. You'll have that in your Bactilec with Ma'am Teddy. Si Coxiella burnetii lang pwedeng airborne, pwede po siyang vector. Because the other of rickettsial organisms ninyo, most of them are vector-borne. Like mga ticks, mga mites, mga fleas, inana. Most of the other rickettsial organisms. But si Coxiella burnetii, pwede siyang airborne, pwede po siyang vector-borne. Please take note. Okay? Alright, ayan. Ayan. That's for diseases of bovine origin. So meaning, these diseases affect humans. Alright? And next, diseases of human origin, meaning gikan sa humans ang kagaw, iyang gi-infect ang cow or kabaw ba, or baka. So typhoid fever, salmonella typhi, salmonellosis or enteric fever, other species, caused by other species of salmonella. Scarlet fever, of course, by Espayo. Cholera, Vibrio cholerae. Diphtheria, C. diphtheriae. Septic sore throat, S. pyogenes. And human TB, of course, M. tuberculosis. Now, naay questions po ni gawas from dirif sa boards, like, milk-borne disease caused by of bovine origin, mga inanang questions. So, hatagan mo og kagaw asa ana nila ang disease, ang bovine origin, or like diseases of milk-borne disease of human origin, mga inana. Then hatagan mo og mga disease asa ana nila ang human origin inana. So, ako ra siyang gi-appeal jud kay base niya ma-include sa boards ninyo puhon. Alright, but this will be emphasized naman in your review. Pero as early as now, at least you're aware. Okay. Alright, so yes guys, so that's the end of it all. That's the end again of our pre-recorded lectures sa bacteriology. And basically sa tanan akong subjects po, this is the last na ako na pre-recorded lecture. It's really quite sentimental for me, emotional kay murag. This is my first year of teaching, and you know, I was murag subjected to this kind of environment. I was really looking forward to the first semester with you guys, no, in our lab classes. Kaya I was really excited to have hands-on activities with you, like sa streaking sa bacte, for identifying the unknown, unta ninyo, hatagan na tamo og broth, niya kamo na mo identify using biochemical tests, mga primary plates, etc. And all that. So I was really looking forward to this semester unta. Okay, you know, I plan not to to stay long here. Diba? Murag kaila ko na ko, char. I plan not to stay long here kaya I have other plans pod. So, but sige lang, I'm just really grateful that I was able to at least teach pa rin in this way. Although I know na pa inadequacies na pa'y kulang in terms of samot na sa hands-on skills, no? But sige lang, bawion lang nato na siya puhon when there are face-to-face classes na gyud. All right? And before your internship, hopefully napakuha na time sa ICLS pod so that I can still teach or I can help you in ways that I can. All right? So again, I appreciate all your efforts. I know you've been through a lot this semester. So the mere fact that you're viewing this, akong pre-recorded lectures, listening, and commending, some of you commending that nice akong pag-lecture. Thank you so much. I appreciate it. I'm just inspired by also my previous teachers sa muta sa review because they're really great educators. So in a way, it motivates me to also spread the same. So thank you so much. Again, di rin ako itangtangon tanan akong video sa YouTube, mga memories na siya. So, again, if you want to watch them again, okay ra gyud. So, my ultimate goal lang yun is, even though inani ato setting na dili jud ideal, dili traditional, I still hope na mo nakuha gyud from me, bahala gamay ra, basta nara jud mo na retain. And that in the future, if ever mag-review mo or ma-encounter nyo sa exam, ning atong mga questions or ako mga questions sa atong exams or sa atong gipang discuss, makayo mo na, okay na, explain na ni Sir Mark, okay na kayo, easy na jud, wala na problema, na. So, muna siya, dears, it was really a memorable, challenging, stressful semester, but I appreciate everything. Thank you so much, good. Thank you. Mura to siya. And I do hope, jud na mo na learn. Thank you so much for being with me throughout the semester. And again, as what I always say, if you have any questions, feel free to chat me and chat sa atong group chat. And I'll see you guys wherever mangani, wherever and whenever. Siguro kung RMTs na mo or intern bagani next sem, just claim it, no? And I know you can do it. I believe in all of you. All right? So, laban lang, okay? And thank you, dears. Thank you so much. Have a great day and keep safe.